Okay, today we are going to start Unit 5, okay, which is about analytical geometry. Lesson 1, it's related to the distance between 2 points, okay? If there is 2 points like this, and I want to get the distance between these 2 points, A and B. So there is one rule, okay, to get the distance between these 2 points. Actually, the rule is x2 minus x1 squared plus y2 minus y1 squared, okay? The square root of this value. Okay, guys? So this is the rule of the distance between 2 points. It's x2 minus x1 squared plus y2 minus y1 squared. What's x2 and x1 and y2 and y1? Actually, this is the coordinates of the point. For example, if this point, its coordinates are 2 and 3, and this point B, its coordinates are 5 and 6, for example. Okay, so now the distance between them, x2 minus x1 squared plus y2 minus 1 squared, the square root of this value. This one actually is x1, and this one is x2, and this one is y1, and this one is y2. Okay? Are we clear about this, guys?
Yes.
Okay. So let's solve one example about this, okay, so that we can understand this point well. If A is 3 and 6, and B is -1 and 4, find the length of AB. Okay, now the length of AB, guys, will equal the square root of x2 minus x1 squared plus y2 minus y1 squared. So it will equal the square root x2 minus x1. Where is x2 here? Actually, -1 minus x1. So -1 minus 3 squared plus y2, which is 4, minus y1, which is 6. So 4 minus 6 squared. So it will equal -1 minus 3 means a -4 squared plus 4 minus 2, sorry, 4 minus 6, which is -2 squared. So -4 squared means 16 plus -2 squared, which is 4. So it will equal the square root of 20. Square root of 20 actually equals 4 times 5. So this 4 outside the square root, it will equal the square root of 4 means 2, square root of 5, then length unit. Okay, guys, are we clear about that?
Yes.
Yes, Mr.
Okay, so do you have any questions till now?
No, thank you.
No, thank you.
Okay, so let's now there are a lot of questions we have to solve, like this one. If the distance between 2 points A and 5 and 3A minus 1 and 1. The distance is 5. Find A. Okay, now the distance between these 2 points equal 5. So 5 will equal the square root x2 minus x1. x2 is 3a minus 1 minus a. 3a minus 1 minus a squared plus y2 minus y1. So 1 minus 5 squared. So 5 will equal 3a minus 1 minus a. So 2a minus 1 squared. 2a minus 1 squared plus negative 4 squared. Okay. So right now, guys, I'm going to square the two sides. Okay. I mean that this term squared and this term squared. So the first term, 5 squared, means 25. And the other term on the other side, squared, means the terms which is under the square root. So 2a minus 1 squared plus negative 4 squared. Are we okay till now?
Yes.
Okay, great. So 25 equals 2a minus 1 squared plus 16. Then 2a minus 1 squared will equal the 16. I'm going to shift it to the other side. Of course, it's positive, so it will be negative value. So 25 minus 16 means 9. Okay. Now, this one, 2a minus 1 squared. So 2a minus 1, I will take the square root. Okay, so it will equal positive or negative 3. Okay, positive or negative 3. Okay, now let's clear this part from the board so that we can continue the solution. So first, 2a minus 1, 2a minus 1 equals, we said that positive or negative 3. So if it will equal 2a minus 1, if it will equal 3, therefore 2a will equal, shift the negative 1 to the other side with positive. Okay, so 2a will equal 4, so a will equal 2. Otherwise, if 2a minus 1 will equal the negative 3, so in this case, 2a will equal, shift this one to the other side, so 2a will equal negative 2. So a will equal negative 2 over 2, which is equal negative 1. So a will equal 2 or negative 1. Are we clear about this one, guys?
Yes.
Okay. One more example. A is 2 and 5. B is negative 1 and 1. Find again AB. Okay. Again, guys, we said that the distance between 2 points, A and B, or any 2 points, equals the square root of x2 minus x1 squared plus y2 minus y1 squared. Okay. Guys, by the way, you know, also it can equal x1 minus x2 plus y1 minus y2. You know why? Because now if x2 is 2 and x1 5. So consider that this one is x1 and this one is x2, for example. So x2 minus x1 means 5 minus 2, right?
Yes.
And the x1 minus x2 will equal 2 minus 5. This one will equal 3 and this one will equal negative 3. Both of them are squared. So finally, this one will equal 9 and this one also will equal 9. So x2 minus x1 is the same like x1 minus x2 because it's a squared term. Okay? So there is no difference. Okay, let's continue. So it will equal the square root of x2. x2 here, negative 1 minus x1, so 2. So negative 1 minus 2 squared plus y2, which is 1 minus 5. 1 minus 5 squared. So it will equal the square root of negative 3 squared plus negative 4 squared, which will equal the square root of 9 plus 16, which will equal square root of 25. So it will equal 5 length units. Length units. Okay, guys, is it clear?
Yes.
Yes, Master.
Okay, great. The next question. If A, B, C is a triangle where A 0 and 0, B 3 and 4, C negative 4 and 3. Find the perimeter. Find perimeter. Triangle like this one, guys. A, B, C. I want to get the perimeter. Perimeter of the triangle means AB plus BC plus CA, right? The perimeter will equal AB plus BC plus CA. Okay, now I want to get AB and BC and CA. So AB will equal and BC will equal and CA will equal. Okay, AB, the first one, x2 minus x1, so 3 minus 0. Okay, 3 minus 0, so 3. Okay, so 3 squared means 9 plus y2 minus y1. Okay, so 4 minus 0 means 4. Okay, 4 squared means 16. So it will equal the square root of 25, which will equal 5. Okay, so AB will equal 5. Great. Then BC, x2 negative 4. Okay, minus x1, which is 3. So negative 4 minus 3, so negative 7. Negative 7 squared means 49. Plus y2 minus y1, 3 minus 4, negative 1 squared, so 1. So the square root of 49 plus 1 means the square root of 50. Okay? Square root of 50, guys, actually equals the square root. 50 means 25 times 2. So 25, the square root of 25 means it will equal 5, then the square root of 2. Okay. So BC 5, a square root of 2. Now get CA. Okay. x2 minus x1 and plus y2 minus y1. Okay, so it will equal negative 4 squared, which is 16, plus 3 squared, plus which is 9. So square root of 16 plus 9, which will equal square root of 25. So it will equal 5. Now the perimeter will equal 5 plus 2 square root of 5 plus 5. So now I can add 5 and 5. So this means it will equal 10 plus 2 square root of 5. Okay? So this is the perimeter of the triangle ABC. Okay, guys, is it clear?
Yes, Mr.
Okay, great. Great. The next question. Prove that the triangle ABC is equilateral triangle. Equilateral triangle, guys, means the three sides are equal, right? So now this is the triangle ABC. We want to prove that all sides are equal. So AB equals BC equals CA. Prove that it's equal. Prove that it's equilateral. Then find the area. Okay. A equals 6 and 0. B 2 and 0. C 4 and 2 square root of 3. Okay. Like before, exactly, guys. I will get AB and BC and CA. That's it. Then I will check that they are all equal. So this triangle is equilateral. Okay, so AB will equal the square root of x2 minus x1. So here AB, so x2 means 2 minus 6. Okay, means negative 4 squared. So 16 plus 0, so 0. Okay, because 0 minus 0 equals 0, and 0 squared means 0. So this one equal the square root of 16, which is equal 4. The next one, BC. Okay, the square root of 4 minus 2, which is 2. 2 squared means 4, plus 2 square root of 3 minus 0 squared. Guys, 2 square root of 3 minus 0 squared. So this term is squared. 2 squared means 4. Square root of 3 squared means 3. So 4 times 3 means 12. So here 12. So it will equal the square root of 16. So it will equal 4. Okay, till now 2 sides are equal. Great. Then we have to get the third side length to prove that they are equal, so that the triangle is equilateral. Okay, CA, 4 minus 6, negative 2. Negative 2 squared means 4. Plus 2 square root of 3 minus 0, again, 2 square root of 3 squared, so 12. So it will equal also the square root of 16, which is equal 4. Now this one, AB equal BC equal CA, so the triangle is equilateral. Okay. Now, guys, I want to get the area. The area of that triangle, equal half base times height. Okay. Just 1 second, guys. Half base times height. So area will equal half base times height. Half base times height. Okay, type. So area will equal half. Where is the base here? It's BC. Okay, BC. So
مستر
BC, yes,
البي سي ده اللي احنا جبناه اللي هو 4.
yes. Any one of them you can consider it as a base because okay it's equilateral triangle.
تمام يا مستر فهمتها. بس هنا ده هو equilateral، فهنا AB دوت 4 وبي سي 4 وسي اي 4.
بالظبط because they are the three sides are equal so it's equilateral.
تمام يا مستر فهمتها.
Okay. طيب الاريا will equal half base times height. طب I will stop at this point. Why? I have the base but I don't have the height, so I will consider that this one will be the height AX for example. Okay, so this point X will be at the midpoint of the base BC. Okay, so this means this point, okay, will be on the middle here, right? So now I will get the height using the Pythagoras theorem. So AX will equal AC squared. 1 second, I will write it here. AX will equal the square root of AC squared minus CX squared. Are we clear till now? It's a Pythagoras theorem. Okay, so the height AX will equal AC squared. It's 4 squared. Where is AC or CA? Yes, 4 squared means the square root of 16. Okay, minus CX. CB is 4 and X at the midpoint. So this means this 2 and 2. So 16 minus 2 squared, which is 4. So it will equal the square root of 12. Okay. Now, guys, half times base equal 4, and the height is the square root of 12. That's it. So let me clear this part so that we can continue. Now it will equal 1 over 2 or half times 4, which is equal 4 over 2, so means 2 square root of 12. Okay? Square root of 12 actually equals 4 times 3. Now take the square root for 4, so it will equal 2. 2 times that 2, which is already outside, so it will equal 4 square root of 3. So this is the area. And of course, square units, 4 square root of 3. Now this one is clear, guys?
Yes, Mister.
Any questions? Any questions till
No,
now?
thank you.
Okay, great. Then the next example. ABC is a triangle, okay? Prove that it's isosceles. Isosceles triangle, guys, means there are two sides are equal. So A, B, C, like this. A, B, C. So how to prove that it's isosceles? We will get AB and BC and CA, okay, to check if there are two sides are equal or not. If there are two sides are equal, so that it's isosceles, okay? So equilateral means three sides are equal. Isosceles means two sides are equal, okay? So the coordinates of A, 3 and 3. Coordinates of B, 5 and 9. And then C, -1 and 7. Okay, now get AB to will equal the square root x2 minus x1 squared, 5 minus 3 means 2, 2 squared means 4, plus 9 minus 3 means 6, so 6 squared, 36. So it will equal the square root of 40. Okay. Now get BC. It will equal the square root of x2 minus x1. So negative 1 minus 5 means a negative 6 squared, 30 plus 9 equal 2. Okay, negative 2 squared, so 4. So it will equal also square root of 40. Okay, so now guys, AB equal BC. So it's isosceles triangle. That's it. Okay, guys, are we clear?
Yes, Mister.
Okay, great. The next point is how to prove that, okay? How to prove that 3 points are collinear, okay? Collinear means, guys, the 3 points lies on the same straight line, like A, B, C. This means collinear. So if there are 3 points like this and I want to prove that they are collinear, so this means the longest one of them, I mean AC, okay? AC will equal AB plus BC? Yes, of course, right? So to prove that 3 points are collinear, okay, we will find the distance between each two of these points. Then we will prove that the greatest distance equals the sum of the two other distances. Sorry, guys. Okay, are we clear?
Yes, we are.
Yes.
Okay, great. So prove that A, which is negative 2 and 7, and B, negative 3 and 4, and C, 1 and 16 are collinear. First, I will get AB. Okay. AB will equal the square root of negative 3 minus negative 2. So this means negative 3 minus negative 2, negative 3 plus 2, so negative 1. Negative 1 squared means 1. Plus 4 minus 7, negative 3 squared, so 9. So this one is equal square root of 10. Okay. The next one, BC. 1 minus negative 3, so 4. Okay. 4 squared means 16 plus 16 minus 4, okay, equals 12. 12 squared means 144. So it will equal the square root of 160. Okay. Square root of 160, guys, actually it will equal 16 times 10. So 16, the square root of 16 means 4. So 4 square root of 10. Okay. Then AC will equal the square root of this one, A and C. 1 minus negative 2, so 3. 3 squared means 9. Okay. Plus 16 minus 7. Okay. 16 minus 7 will equal 9. So 9 squared means 81. So now it will equal the square root of 90. Okay. Actually, square root of 90 equals 9 times 10. So it will equal 3 square root of 10. Okay. Now, guys, this one is square root of 10, AB, and AC 3 square root of 10. Okay, so this means, and BC also 4 square root of 10. So this means BC equal B plus AC. So BC will equal AB here, square root of 10, plus 3, square root of 10. So this means it will equal 4, square root of 10, right? So the longest side, or the longest one, equals the summation or the total of other lines, right? So this means the 3 points are collinear, so that A and B and C are collinear. Okay, guys, are we clear?
Yes, Mister.
Any questions till now?
No, thank you.
Now the next point. If I want to prove that points A and B and C are vertices of a triangle like this one, A, B, C. To prove that A and B and C are vertices, I mean that they are forming a triangle, okay, with this 3 vertex, A and B and C, okay? So the first step, we will find AB and then BC and then AC, okay? And then we will prove that the sum of the smaller 2 sides are greater than the third, okay? So in this case, it will be a triangle, okay? The next point, if we want to know, okay, the type of this triangle according to the angles, okay, so that we will compare between the longest side, we will consider that the longest one is AC, okay? So if AC squared equals AB squared plus BC squared, so this is Pythagoras theorem, yes. So this means this triangle will be right angled. Okay. The second case, if AC squared greater than AB squared plus BC squared. Okay. So in this case, guys, this triangle is obtuse angle. Okay. The third case, if AC squared less than AB squared plus BC squared. So in this case, it's acute angle. Okay? Okay, let's check some examples so that we can understand this point. The first example, prove that the triangle whose vertices are A, 3 and 2, and B, -1, -4 and 1, and C, 2 and -1, right angled. Okay. We said that the steps of solution, we will get AB and BC and AC, and then we will compare between the longest and the other two, okay? So if AC squared, we will consider that the longest one is AC, okay? So if the longest one is squared equal the total of the squared of both of the other two sides, so this means it's right angled, okay? So let's check. First, I will get AB, then get BC, then AC. AB will equal x2 minus x1, so -4 minus 3, so -7, -7 squared, 49, plus 1 minus 2. which is -1. -1 squared means 1. So the square root of 49 plus 1, so it will equal the square root of 50. Okay? Then BC. Sorry, guys. BC, it will equal 2 minus -4, so -6. Sorry, 2 minus -4. So 2 plus 4, I mean, so 6. 6 squared, 36. Plus -1 minus 1, so -2 squared. -2 squared means 4. So the square root of 36 plus 4, which is equal the square root of 40. Okay. Then AC will equal 2 minus 3, which is -1. -1 squared means 1 plus -1 minus 2, so -3. -3 squared means 9. So square root of 1 plus 9, so square root of 10. Okay. So now we said that we have to compare, okay, the longest one with the other two. So now, guys, what is the longest one? Actually, it's square root of 50. So now, square root of 50 which is AB squared equals here 40 and 10. So this means, guys, AB squared, okay, will equal square root of 50 squared, which will equal 50. Okay. Now BC and AC. So BC squared plus AC squared will equal BC here is 40, square root of 40 squared plus square root of 10 squared. So this means it will equal 40 plus 10. So it will equal 50. Okay, so now AB squared equals BC squared plus AC squared. So this one is a right angled. Okay, guys, are we clear?
Yes, sir.
Yes.
Okay, great. Then find the area of this one. Find the area of this one. Okay, let's clear the upper part here. Guys, look at this triangle. Here, AB is the longest, right? So AB, I mean AB, this one, and then this one is C. And we just proved that it's right angled. So this one is 90 degrees. Okay. So to deduce B squared equal AC squared plus BC squared. Okay. So it's right angled. So now if I want to get the area, it will equal the same rule, half base times height. Now it will equal half. Where is the base? It's BC. Okay. So BC equals the square root of 40 times the height, which is AC, because this one is right angled, so this one is the height, okay, because it's perpendicular to BC. So AC equals the square root of 10. Now, guys, it will equal half, then square root of 40 times square root of 10 means the square root of 400. So it will equal 1 over 2 square root of 400, guys. Actually, it will equal 20. So it will equal half times 20. So this means that the area will equal 10 square units. That's it. Are we clear about that?
Yes.
Okay,
Yes.
very good. Any questions? Any questions?
No.
No, thank you.
Okay, great. Then the next point, guys, if there is a quadrilateral like this one, okay? I mean 4 sides. Any shape with 4 sides is a quadrilateral, okay? So quadrilateral means 4 sides, whatever it's shaped. So the square is a quadrilateral, the rectangle is a quadrilateral, the parallelogram is a quadrilateral. All these shapes are quadrilateral. So quadrilateral means 4 sides. Okay, guys, are we clear?
Yes.
Yes.
Okay, so the first point, if I want to prove that ABCD, for example, ABCD is a quadrilateral, if I want to prove that it's a parallelogram, parallelogram like this, guys, ABCD. If I want to prove that it's a parallelogram, okay, so just prove that each two opposite sides are equal. So AB equal to CD and BC equals to AD. So this one will be a parallelogram. Okay, guys, are we clear?
Yes.
Yes.
Yes, Mister.
Okay, to prove that it's a rhombus. To prove that it's a rhombus like this one. We know that the rhombus, guys, all sides of the rhombus are equal, okay? So just we will prove that the 4 sides, which are AB equal to BC equal to CD equal to DA. That's it. So if we will prove that they are all equal, so it's a rhombus. Okay? Next point. If we want to prove that ABCD is a rectangle like this, ABCD is a rectangle. So in this case, guys, we have to prove that AB, of course, equal to CD, and BC is equal to AD. Okay? And also, guys, the two diagonals, I mean AC and BD, AC equal to BD. So in this case, it will be rectangle. Are we clear till now?
Yes.
Okay. If it's a square, guys, if it's a square, A, B, C, D. So in this case, all sides inside the square are equal. So I will prove that AB equal to BC equal to CD equal to AD. And also the two diagonals are equal. So AC equals BD. So in this case, it will be a square. Okay, guys, are we clear?
Yes.
Yes, we are.
Okay. Great. So the first example, guys, the first example. If A 3 and -2 and B -5 and 0 and C 0 and -7 and D 8 and -9. Okay. Prove that ABCD is a parallelogram. Okay, parallelogram like this. ABCD. Okay, now I said that to prove that the quadrilateral is a parallelogram, we have to prove that each two opposite sides are equal. So I want to prove that AB equals CD and BC equal to DA. That's it. So simply I will get AB and CD and BC and AD, right? So this one equal the first one AB, -5 minus 3, so -8 squared, 64 plus 0 minus -2, so 2 squared, 4. So it will equal the square root of 68. Okay. CD, 8 minus 0 means 8, so 64, 8 squared. -9 minus -7, so it will equal -9 plus 7 means a -2 squared means 4. So also square root of 68. Okay. Okay, so the first step we finished. AB equal to CD, great. Then BC and AD. BC, it will equal 0 minus -5, which will be 5 squared, 25, plus -7 minus 0, so 7, 7 squared, 49. Now it will equal the square root of 74, I guess. Then AD, 8 and 3. So 8 minus 3, 20, it will equal 5 squared, 25, plus -9 minus -2, so -7 squared means 49. So it will equal the square root of 74 also. So now, guys, AB equals to CD and BC equal to AD. So each two opposite sides are equal. So this one is a parallelogram. That's it. Is it clear?
Yes.
Any questions till now?
No.
Okay, great. The next point, guys, there is one question and we want to prove that one is a rhombus. Okay. So prove that the points A, -1 and 4, okay, and B, 1 and 1, and C, -1 and -2, and D, -3 and 1 are vertices of a rhombus, and graph it. Okay, then find its area. So I want to prove this one is a rhombus, then graph it, then find the area. Okay, we said that if it's a rhombus, guys, like this, so this means A, B, C, D. We said that all sides are equal. Okay. Okay, now I'm going to get AB, BC, CD, AD to make sure that they are all equal so that we will prove it's a rhombus. AB means 1 minus -1, so 0. So the square root of 0 plus 1 minus 4 means -3 squared means 9. So it will equal the square root of 9, which will equal 3. Okay, so the first, just 1 second, guys. It's I have to check something. -1 and 4, 1 and 1, -1 and -2, -3 and 1. Yes, exactly. So AB. Sorry, guys. It's 1 minus -1 or -1 minus -1. So 2. Okay, squared means 4. Why 0? It's 4. 2 squared, 4. So it will equal the square root of 13. Square root of 13. Then the second one, BC, -1 minus 1, so -2. -2 squared means 4 plus -2 minus 1, -3 squared means 9. So also square root of 13. CD, -3 minus -1, so 2. 2 squared means 4 plus 1 minus -2, so 1 plus 2 means 3, squared means 9. So it will equal also square root of 30. Okay, then the last one, AD. AD will equal -3 minus -1, so -2 squared means 4, plus 1 minus 4, -3 squared means 9. So here it will equal square root also of 13. So AB equal BC equal CD equal AD. So this one is a rhombus. So that was the first requirement. Then graph it. Okay, it's very easy. This is the two planes, X and Y, on a graph paper. And this one, X dash and Y dash. Then 1 and 2 and 3 and 4 and the -1 and -2 and -3. Of course, you have to draw it or to graph it on a graph paper with a accurate scale. Okay, 1, 2, 3, and 4. Then -1, -2, -3, and -4. Okay, then represent your points. A, -1 and 4. -1 and 4. So it will be here. This point. Then 1 and 1. 1 and 1. This means here. Then -1 and -2 means here. Then -3 and -1. Sorry, -3 and 1. -3 and 1 will be here. Now connect between the lines like this. It will becomes a rhombus. But of course, because I'm drawing using my hand, okay, there is no scale, there is no ruler, so it becomes like this. But anyhow, you have to draw it like this way. Okay, guys, are we clear?
Yes, Mister.
Yes.
Okay, great. So this points now, this one is A, and this one is B, and this one is C, and this point is D. Okay. Now find the area, okay? Find the area of this rhombus. Okay, how to get the area, guys? How to get the area? Actually, guys, okay, if we want to get the area of the rhombus, okay, area of the rhombus equals, I will write it here. Area equals half diameter 1 times diameter 2. Again, because this one is not very clear. Area will equal half D1 times D2. Okay. Now I want to get the diameters. So this means I want to get AC and BD, right?
Yes.
Very easy. Let me clear this part. No need for this one now. And just we will get AC and BD. Actually, it's very easy like before. Just 1 second, I'm clearing the board. Okay. So first AC. AC, it will equal the square root of -1 minus -1. Okay, so -1 minus -1 means -1 plus 1, which is 0. Okay, then plus -2 minus 4, so -6 squared, 36. So AC will equal the square root of 36, which will equal 6. Then the other diagonal, BD, will equal the square root BD. So -3 minus 1, so -4. So -4 squared, 16, plus 1 minus 1 means 0. So 16 plus 0. So it will equal the square root of 16, which will equal 4. Now get the area. Half diameter 1 times diameter 2. So it will equal 4 times 6, 24, 24 over 2, which will equal 12 squared units. Okay, guys, are we clear till now?
Yeah.
Yes.
Okay, great. Okay, let's continue to the next point. Actually, the next point, guys, okay, it's about the axis of symmetry. Axis of symmetry of a line segment like this one. If this one is A and this one is B. So the axis of symmetry of this straight line, okay, actually it's perpendicular to this line, and also it will be at the middle, okay? So this means it will be like this and also perpendicular and on the middle. So the point D will be at the middle of AB. So this one equals to this one. Okay, so now if I will consider that this point is C, so CD is the axis of symmetry, okay, of the straight line or the line, sorry, the line segment AB. Okay, any point on the straight, on this axis of symmetry, I mean, any point here, okay, on the axis of symmetry is at equal distance from its terminals. Like what? Like if there is point C here, so this means CD is the axis of symmetry, so CA equals CB. If there is one more point here, F, so FA equals FB, and so on. Okay, guys? This one equal to this one, and this one equal to this one. So any point lies on the axis of symmetry, okay, at the same distance from its terminals. Okay, guys, are we clear?
Yes.
Also, guys, if it will be the converse of this point, if there is a point at equal distance from two terminals, like this point, okay, lies here on this straight line, and it's at equal distance from the terminals of AB. So this means this line, which is CD, G, for example, okay, CG, this one, will be the axis of symmetry for this line segment. Okay, guys, are we clear?
Yes.
Okay, great. So let's solve one question related to this point. Okay. Let's clear the board. Okay, if A 1 and negative 1, A 1 and negative 1, and B 1 and 3. Okay, prove that the point C, which is negative 1 and 1, lies on the axis of symmetry of AB. Okay, so let's consider that this one is AB, guys. Okay, AB. We want to prove that C lies on the axis of symmetry. So if this one is the axis of symmetry, so we want to prove that C lies on this axis of symmetry, like this. So simply, guys, we want to prove that AC equal to CB, right?
Yes.
Okay, that's it simply. So this type of questions actually is very easy. So first, I'm going to get CA equals and CB equals. If they are equal, okay, so this means the point C lies on the axis of symmetry of AB. So CA equals the square root CA, so negative 1 minus 1, so negative 2 squared means 4 plus 1 minus negative 1, okay, means 1 plus 1 means 2, so 4, okay? So it will equal the square root of 8. Square root of 8, actually 8 means 4 times 2. So 4 square root of 4 means it will equal 2 square root of 2. Okay, so this is CA. What about CB? C and B. Negative 1 minus 1 means negative 2. Squared means 4. Plus 1 minus 3, negative 2. Squared means 4. So the same, square root of 8, which is equal to square root of 2. So CA equals CB. Therefore, the point C lies on the axis of symmetry of AB. Now it's clear, guys? Okay, great. Okay, guys, next point. How to prove that if there is a circle like this with center M, how to prove that this point B and point A and point C, okay? How to prove that this 3 points, okay, lies on the same circle, okay? So it's very easy. This is the center. So this means MA radius, MB radius, MC radius, right? So I will prove that MC equals to MB equals to MA. That's it. So in this case, guys, the 3 will be equal and the 3 will be a radius for the circle so that I can prove that they are lies on the same circle. Okay?
Okay.
Okay. So guys, if this point or one of these points lies on the circle, okay? So this means MA will be a radius, MB will be a radius, MC will be a radius, right? Okay, guys, great. Remember that, guys, area of the circle equals by R squared, okay? By R squared. Okay, so we studied before that by R squared. By equals 22 over 7 or 3.14. Okay, and R is the radius, of course. Okay, what about the circumference? Circumference of the circle equals 2 by R. Okay, guys, are we clear? So
Yes.
the area by R squared, the circumference 2 by R. Okay? Okay, so let's solve one question. Prove that the points A, negative 6 and 2, B, 0 and 8, C, negative 8 and 4, lies on the same circle whose center is M. Circle like this, and there is M here. And this point M is negative 4 and 6. And find the area whereby approximately equal 3.14. Okay. So guys, we want to prove that A and B and C lies on this circle. So I want to get if this one is A, if this one is B, if this one is C, like this, A, B, C. I want to prove that they are lies on the same circle. So MA have to equal MB, have to equal MC, right?
Right.
So the first step, I'm going to get MA and MB and MC. Sorry, this one M. Okay, so MA will equal the square root of MA. So negative 6 minus negative 4. So negative 6 plus 4 means 2. Okay. Squared means 4. 2 minus 6 negative 4 squared means 16. So it will equal the square root of 20. Okay. The next one, of course, the square root of 20, to simplify it, 5 times 4. 4 means square root of 4 means 2. So 2 square root of 5. Okay. The next one, MB. 0 minus 4. Okay, 0 minus negative 4, so 4. Okay, squared means 16 plus 8 minus 6, 2 squared, 4. The same, square root of 20. So it will equal to square root of 5. Okay. MC, negative 8 minus negative 4. So negative 4. Negative 4 squared, 16. Plus 4 minus 6, negative 2 squared, 4. So it will equal the same, square root of 20. Also 2 square root of 5. Okay, so MA equal MB equal MC. Yes, so the points A, M, B, and C lies on the same circle. Okay, whose its center is M, and the radius now, guys, equals MC or MB or MA. So radius will equal what? 2 square root of 5, right? Okay, then find the area. Area of the circle. We said that area equals, what is the rule of the area? Pi r squared. So it will equal, it's given that pi equals 3.14 times r squared. 2 square root of 5 squared. So 2 squared means 4. Square root of 5 squared means 5. So using the calculator to get the result, it will equal 62.8 square units. Okay, guys, are we clear?
Yes, Mister.
Yes.
Okay, very good. So do you have any questions about this lesson? Because actually we reached the end of this lesson. Okay, so any questions, guys?
No, thank you.
No.
Okay, great.